Graphing absolute value. So what you'll know it's an absolute value equation because it's going to have those big absolute value bars in it. So whenever we graph absolute value, like remember when we were graphing lines, we wanted to pick out the slope and the intercept, and we plotted the intercept, and then we counted. So for these, we're always going to make an XY table and just plot the points. So you're writing in your notebooks, right? Graphing absolute value.
What? What just happened?
And then
These are our notes.
these are our notes we're writing down, right?
Yeah?
Yeah.
Oh, my bad.
So if I'm going to graph absolute value, my equation looks a little bit different. Like before we saw y equals mx plus b, our absolute value equations, we're going to use f of x equals the absolute value of x. So you'll know it's not going to be your linear equation because it's going to actually have those absolute value bars in it. Then when we go to graph these, I'm going to plug in -2, -1, 0, 1, and 2, just like the numbers that we plugged in our UNAP. We plugged in some x values, got out our y values, right? And then we're going to plot them. So we're going to take this -2, and we're going to replace x with a -2. So we would have absolute value of -2. So the absolute value of -2, and we know the absolute value of -2 is really what? 2. So that means that my coordinate here is -2 for my x and 2 for my y. So I'm just going to get a bunch of coordinates and then I'm going to plot them. So far, so good?
Yeah.
Okay, so then I'm going to plug in -1. And when I plug in -1, I get the absolute value of -1, which is 1. So now I have the point -1, 1. It's a lot of lines, right? Then I plug in 0. And I get the absolute value of 0, which is just 0. Then I plug in 1. Absolute value of 1. Is it -1 or +1?
-1.
Positive, right? Absolute value tells us always make it positive. So if it's already positive, I don't have to change it. I can just get rid of the absolute value bars. And then absolute value of 2 is 2. Yep, so I've got 0, 0 here. 1, 1, and 2, 2. Do you want sticky grass?
Yes.
Y'all want to know what I learned yesterday?
Huh?
Y'all want to know what I learned yesterday? Megan Trainor, she dates the kids from, she's married to the kids from Flight Kids.
Let's go. So we're going to physically just plot the points, and that's going to give us a picture of our graph. Shake it up. Shake it up.
I don't even remember my schedule for today. I know I got you and Mr. Katz, and then I think Spanish.
You're doing a really good job of putting this in your notebook and drawing it, right?
Yep.
So you're going to go in, you're going to draw your x-axis.
Those virtual kids are missing out on these sneaky things.
You Mr. Cat?
Focus.
Who's Mr. Cat?
The biology teacher.
You're going
He's
to
not?
No.
focus. Focus. Then we're going to draw our y-axis, right? And now I've got to plot my points. So if I'm going to plot -2, 2, what do I do?
You go left 2.
Yep.
And then up 2.
Beautiful. I go left 2, up 2, plot a point. What about -1, 1?
Left 1, down 1.
Yep. 0, 0, right in the middle. Do you remember the fancy word for the middle?
Oh!
Margin.
Close.
No. It's not, I remember it, but I don't.
Origin. Yes, origin. Close to margin.
What is a margin?
Margin is the side of your paper that you don't write in.
On the other side of the red line.
Yeah. Or like when you're typing a document, it's the parts outside that the words don't go on. Origin. Origin is the middle of your graph. Then I've got 1, 1, which is right 1, up 1, right? Oh, interesting. And then 2, 2. What kind of shape does that look like?
The triangle.
Kind of, right?
Yeah. Wait, why does mine look so different from yours?
I'm not sure.
Why does yours look like an animal?
I don't know what I did, but this is how mine turned out.
Because you went back 1, down 1. Instead
Oh
of,
yeah, I went down one.
Yeah.
Yours look like an animal. Mine does. Oh, mine does too.
Okay, so now if I'm going to connect the dots that I had, right? I went from here to here, here to here, here to here, and here to here.
Yep.
Now, I'm not going to go and close it off because I'm not going to go back to where I started, right? That would just be weird. If I plugged in a 3, what's the absolute value of 3? 3. So it would keep going, right? What's the absolute value of 4?
4.
4, right? It just kind of keeps going. It's going to be 5 and then 6 and it'll keep going. What about what's the absolute value of negative 3? 3. So this side's going to keep going too. Oh. Look at that. What kind of shape does that look like?
A
Or
triangle.
letter?
A V.
A V, right? A big old V for absolute value. Value. Look at that. So our graphs before were straight lines. These graphs are going to look like big V's. Because basically what happened was we used to have our graph would continue down like this, right?
Yeah.
And this would have been our whole entire graph. But because absolute value says we always have to have a positive number, it took this part of the graph, this whole section down here, and it made all of those numbers positive, which flipped them up into that center quadrant. That's why it looks like it's going, it like bounces it back up. So we're going to always have V's like this. Now the most important point that we want to make sure we always find is going to be our vertex. And our vertex is that point where it's changing direction. So,
0.
so on here, yeah, our vertex right now is the point where it's changing direction. So if we're going to label that or explain it to ourselves, it's the point on the graph where the graph changes direction. Or it's kind of like the corner of the graph almost. If you think about it like that, it's right where that corner is. So we always want to make sure that when we're graphing, we include our vertex in our graph. So it's not always going to be at 0, 0. It could end up being at different places. So when we look at what numbers we want to plug into our table, we're going to look at what we're adding and subtracting to x, and we're going to make sure we include that number. So see how if I go back up to the equation, I didn't add, there's nothing happening in here, right? I didn't add anything to my x. It's just an x all by itself. So that's why I wanted to make sure, and that's why my vertex is at 0. So if I have a number that I'm adding to the x inside the absolute value, I want to make sure that I use that number in my table. Otherwise, I might not find my vertex. I might end up missing it and end up with just a straight line. Does that make sense? Kind of?
Yeah.
Okay. I'll show you more. But so basically, I don't know what this is doing now. So when we go to pick out the numbers to put in our table, we want to always use the number being subtracted from x that is inside the absolute value. Because we want to make sure that we have our vertex included in our graph. Because if we miss our vertex, we're just going to end up with a part of the V, and we're not going to know where that corner is. And we need to make sure we have that corner so that we know what the shape looks like. You want to see what I'm talking about in actual numbers?
Sure.
Okay. Are you ready for me to move this? Okay. Just don't go crazy. All right. So if I gave you, for example, number 1, I said graph g of x equals the absolute value of x plus 3 and identify the vertex. So we're going to graph it and we're going to tell them what the vertex is. Now, when I go to pick out the numbers in my table, I want to make sure I'm using numbers that are going to include my vertex. So that's why I was saying we want to look at the x value. We want to look at what's happening inside the absolute value, and we want to see, is there anything being added or subtracted to the inside of the absolute value? Do you see any numbers being added or subtracted inside the absolute value? No. So that tells me I want to make sure that I use 0 as one of my x values to plug in. Because I'm not adding or subtracting anything. I wouldn't write that I added or subtracted 0, so that's the number I want to make sure I use. So when I go in and write my table, I like to look at the number that's being added or subtracted inside the absolute value, and that's the first number I like to put in my table, so I normally put it right in the middle, because I know the vertex is right in the middle of my graph, so now I can see that my vertex has an x value of 0.
Oh, I put this on wrong.
And then I'm going to pick numbers on either side. So I'm going to pick a number smaller than 0, bigger than 0. And I want to have like 5 numbers on there so I can get a good idea of what's happening. Are you okay with how I got my x values? Because that's going to be the hardest part. Because if I had just done 1, 2, 3, 4, I'm going to end up with a straight line because I'm going to miss my vertex. Not always, though. So the reason mine looks like this is because when I look up here, I didn't add anything, right? I'm adding 0. There's nothing being added to x. I'm adding a 0. So 0 was the middle number. 0 is where my vertex is going to be. So I put 0 in first and then pick numbers on either side of my vertex.
Okay, it doesn't matter what the numbers are.
No, I just picked the closest ones, the easiest ones to plug in.
And what if there wasn't? What if there wasn't?
So we're going to look at that example next and pick numbers from there. But basically, if I was subtracting 3, then I want to put a 3 as my vertex, and I'm going to pick numbers on either side of 3. So whatever number is in the absolute value, I'm going to take the opposite side of it and put that as my vertex. Okay, and we'll look at an example like that. So now, in order for me to get my y values, what do I have to do?
Do the opposite.
I have to plug my x values in, right? So I'm gonna plug in -2, which when I plug in -2, that means I get the absolute value of -2 plus 3. Are you okay with that? Because I just took this entire equation, right? This whole thing, and I replaced the x value with a -2. What happens when I have the absolute value of -2 plus 3? What do I get?
5.
5, right?
Yeah.
Yep. Because absolute value of -2 is 2, plus 3 is 5. So now I've got to do that for -1, so I'll have the absolute value of -1 plus 3, which gives me what?
4.
4. Then I'm going to plug in 0, so I get absolute value of 0 plus 3. Absolute value of 0 is just 0. 0 plus 3 is 3. So now, if I correctly picked my vertex, I should get 4 for my next number. Because it should start, the pattern should repeat itself. So since I got a 4 before there, I should get it after it too. So let's check to see if I got it correct. Absolute value of 1 plus 3. 1 plus 3 is 4, yay! And now I should get 5 next because my pattern should complete itself. So absolute value of 2 plus 3 equals 5. Woohoo! So now I'm going to go in, I'm going to draw my x-axis. I'm going to draw my y-axis. And then I'm going to plot my points. What's the first point I'm going to plot from that?
The first one.
I'm going to plot that top one, right, which is
Yeah.
-2 for my x. And what's my y value there?
5?
So -2 and 5. Sometimes it's a little tricky to read because our work is in there too. So it's -2 and 5. Then I'm going to use -1 and 4, 0, 3, 1, 4, and 2, 5. So if it helps you, write the coordinates down the side for yourself and then graph the coordinates. So then I go in, I go back 2, and I go up 5. 1, 2, 3, 4, 5. And then I go back 1 and up 4. 0, 3, 1, 4, 2, 5. So I noticed that I have the same shape as last time, right? I still have my V. It just, instead of being at 0, 0, it's at 0, 3, the vertex. So just kind of, the graph is just going to move around. So what's going to happen is you're going to keep having these V's. They're just going to be in different locations. They're going to start at different points. The vertex will be at a different point on the coordinate grid. So it's still going to look like the V. It's just going to be in a different place. So if I asked you, because we also had to identify the vertex here, right? So if they asked you to identify the vertex, they just want the coordinate of the vertex. So what's my coordinate here?
3,
0,
0, 3.
0, 3, right? I went over 0 and up 3. So I would say my vertex is at 0, 3. Let's try one more and then we'll look at the classwork together. Okay? So the next one says, graph f of x equals the absolute value of x plus 2 minus 3 and identify the domain and range. Ooh, throwback. With a good review right before you have to take a test on all this stuff.
Whoop.
Whoop.
Why are we taking a test?
Whoop. Next week.
Oh.
Whoop. This is the last thing we have to do in this section.
Mine.
Happy Friday!
But guess what?
What?
I'm caught up.
Woohoo! All right, so we're going to graph absolute value of x plus 2 minus 3.
Why is it always a 3?
I don't know, I just seemed to be 3 happy when I made the notes, I guess. Well, I guess it was my favorite number that day. All right, so the first thing I have to decide is what numbers I want to put in my table, right? So this is the first time that we're seeing something a little bit different inside my absolute value, right? So since I'm adding 2 inside my absolute value, I want to make sure that I start my table, or my middle of my table is going to be at -2. So it's always going to be the opposite sign of what number is in there. Does that make sense? Are you okay with that? I'm always use the opposite sign to start table. So since I have a +2 here, I'm going to start my table. My middle number for my table will be -2. And then I'm going to just pick numbers on either side. So before I wasn't adding anything. I was adding 0 to my x, so that's why my table, the middle of my table was 0. Here, since I'm adding 2, I want to use the opposite, -2. So if I was subtracting 5, I would put a +5 in the middle of my table. If I was adding 7, I would put a -7 in the middle of my table. And then I'm just going to pick numbers smaller than 2, so -3,
Wait.
-4,
Okay.
and then bigger than 2 would be -1 and 0.
Interesting.
Interesting, right? And then I'm just going to plug in, and I'll be able to check myself, and I'll be able to tell if I did it correctly, because I should have that pattern of numbers. My numbers should be the same on either side of my vertex. Beautiful. What happens if I plug in -4?
It goes to +4.
Okay.
I think.
I have to do the operations first. So because this equation is a little bit longer, I'm going to do my operations off to the side and then just put my answer in so that my table doesn't get all sorts of crazy and hard to read. So I'm plugging in f of -4, right? Just like I did in the do now. So I'm saying -4 plus 2 minus 3. So when I do that, then I say, okay, -4 plus 2 is what? -2 minus 3. Absolute value of -2 minus 3.
Oh.
Well, -2, absolute value of -2 is really 2, right? Minus 3. -2.
2 minus 3 will make it 1.
-1, right? 2 minus 3 gives us -1. So then I just put the -1 here.
Oh, now it's how dumb I'm recording.
Huh?
So now it's how dumb I'm recording.
Do you like it better that way? Or do you like doing the work right in the table?
Oh, no, I don't
No,
know.
let's do it on the side.
On the side better, right?
Yeah,
It
that's
kind
how
of,
it works.
it makes it easier to see it all.
Mhm.
Okay, so then let's plug in 3. Or -3, right? We plug in -3, I get absolute value of -3 plus 2 minus 3. Absolute -3 plus 2. What do we get?
-3 plus 2.
Mm-hmm.
1. -1.
-1, right? But it's in absolute value sign, so then +1 minus 3 really gives us -2. All right, you try the next 3 and see what you get. I'm coming to check.
Oh gosh, okay.
No pressure.
Oh,
It's good.
it's not correct.
Wait, you plugged in 4 twice?
Where?
Because you plugged in 4 on the first one in 2 spots.
Well, this is just my notation that says I'm plugging in
That's just
so
so
that when I look at my work, I know this is where I plugged in -4. This is where I plugged in -3.
So the problem is just like single.
It's just this side.
I thought you were gonna erase it off the board when you did that to me.
It's
What do you get? We plug in -2. What do you get?
-2. Or no. Minus 3 right now.
You get 3. You get -3.
-3. Okay. What happens when you plug in -1?
You get
Negative. +2. Right? I don't know.
All right. So we agree this is -3. We need to do the next one. All right. If I'm doing f of -1, I get
-2, right?
-1 plus 2 minus 3.
Plus 2.
-1 plus 2 is what?
0? No.
-1 plus 2.
1.
1. So absolute value of 1
It's -2.
minus 3
I thought
is
that-
1 minus 3 is -2. Oh, yay! That's what we want, right? We wanted it to be the same.
Oh.
We want it should always, if I picked my vertex correctly, when you make your values, your numbers on either side of your vertex should be the same. So when we plug in 0, we should get out what?
1.
-1. So let's check ourselves. We plug in 0. F of 0 equals 0 plus 3. Oop, nope. 0 plus 2. Minus 3. 0 plus 2 is. Come on, this is the trickiest question I've ever asked you. It's 2, right? 2 minus 3. -1. Yay, we got what we wanted.
Yay!
Yay, let's plot these bad boys. We're almost there. X, Y. And then I'm just going to go -4, -1, right? So I'm going to go back 4, 1, 2, 3, 4, down 1. Then I'm going to go -3, -2, -2, -3, -1, 2, 0, -1. So I still have my V shape, which is what I wanted. It's just down in the third quadrant. We just moved it around, which is all that you're going to see. You're going to see it get moved around. What else did this question ask us?
And I didn't find the domain.
To find the domain and range, right? So I'm going to slide it up just so I have room to write. If we're looking for our domain, do you remember what domain means?
Honestly, no, not
It
really.
was so long ago. Domain was our x values.
Oh, yeah.
So domain are the numbers that we're plugging in. So see how my graph, when you look at it, looks like it's getting wider and wider and wider and wider forever and ever and ever, right?
Yeah.
That tells me that I can plug in any number for my domain, which is true because I can find the absolute value of any number, right? And just make it positive. So because my graph is getting wider like this, your absolute value graphs will always have a domain of all real numbers. So this is actually a nice question for them to ask because no matter what your absolute value equation is, if they ask you for the domain on absolute value graphs, it's always going to be all real numbers. We can plug in all x values. We can use any x value in absolute value.
And isn't it the range like
So then the range is our y values, right? Our range is going to be a little bit different because notice when I look at my graph, I don't have anything down here, right? There's nothing, there's no graph down there, but then my graph is going up forever. So what has to happen, I have to find the y value for my vertex. So I want to know this y value, and my domain, or my range will start at that y value. So my y's, it's -3, right?
Yeah.
My y's are going to be bigger than or equal to -3. And this is just the y value of the vertex.
Do I have to write that too?
No, well, I mean, it's helpful in case you forget. So your domain for all of these graphs will always be all real numbers. You can plug in any number. Your range, or the numbers you get out, will always be the y value of your vertex. If the graph is facing up like these, it'll be bigger than the y value of your vertex, right? Because they're getting bigger, it's going up. If the graph was facing down, it would just be smaller than your vertex. Beautiful?
Yep.
All right, let's look at your classwork.